about the IP. So you need to remember IP is nothing but internet protocol. IP is nothing but internet protocol, and it is divided into 5 classes. IP address is divided into 5 classes. We are going to see what is 5 classes, and this is divided by INA. INA is nothing but Internet Assigned Number Authority. This is the organization who is responsible for IP. He is going to give the IP to us. If you are working in the organization, if you want 5 or 10 IP address, that is a public IP. We have 2 types of IP. We are going to discuss that one now. If you want 5 or 10 IP or till 20 IP, you will get from the ISP. ISP is nothing but Internet Service Provider. But if you want more IP, if you need 100 IP or 200 IP, ISP will not give you. You need to contact to INA to get that one. It is not free, they will charge you, but you need to coordinate with the INA. INA is nothing but a organization who is responsible for the IP. So this is the IP, that is a public IP. Public IP means you can access the internet with that IP. Private means you cannot access the internet with that IP. We are going to look that one in the class. So this one, now we are saying it is a 5 classes, and INA is a responsible who is giving the IP. INA is nothing but Internet Assigned Number Authority. And after that, IP also divided into 2 types. We have IPv4, IPv6. We have IPv4, IPv6. Why we are using IPv6? Because IPv4 is finished. IPv4, because when IPv4 is introduced, that time no one imagined that in this earth everyone is going to use the internet and everyone is going to utilize the IP. So IPv4 is finished, almost it is finished. So now already many ISP started using the IPv6. If you see in India, Jio is using IPv6. In many country, many service provider is using the IPv6. Now what we will do, first we will look the IPv4. So IPv4 is nothing but it is a packet. It is going to carry our information. Whatever information we are going to send, he will carry. And again IPv4 is divided into 2 parts. And you need to remember IPv4 is 32-bit. You need to remember IPv4 is 32-bit. And it is 2 parts. One part is a network part, one part is a host part. So you need to remember whenever you are writing any IP, as we are doing the example 192.168.1.1 here. So this is network, this is network, this is network, and this is host. Okay, and we are saying it is divided into 2 parts, means this is one part, that is the network part, and this is a host part. Okay, so now in this class we are going to discuss that in more detail. If you see here, first point you need to remember IPv4 is 32-bit and 2 parts, network and the host path. And this is the example. I wrote IP address 192.168.1.1. Okay, so this one, each block, this is a block, each block is consists of 8-bit. Each block consists of 8-bit. So you have 4 block, you have 4 times 8, 8. So if you see 8 plus 8, again 8 plus 8, this is 16 and this is 16. 16 plus 16 is 32. So what we are saying, 32 bit, 32 bit. So you need to remember IP address is 32 bit, that is IPv4 is 32 bit. Each IP is having the 4 block. Each block is 8 bit. And it is divided into 2 parts. One is network part, one is a host part. So this one, if you see here in our example, this is network. So we have 3 network portion and one is a host portion. And each portion is 8 bit. Okay. So and we, as just now we discussed 5 classes. So I now divide the 5 classes. So now in our real scenario, in our whenever we are configuring, we will use these 3 classes only. And this is for multicast. Multicast means routing protocol. This IP is going to utilize. That is a class D we use in the multicast. That is a router is going to use this one when they are multicasting the information. We are going to see later. Now just remember, we have 5 types of classes: class A, class B, class C, class D, class E. Okay, and these 3 classes, class A, class B, class C, we are going to use in our labs. This one is using by the router, and this is reserved for research and development, so we cannot use this one. Okay, so we will use only these 3 class in our lab. So now the most important thing, before, as we are saying, one network part, two network part, now you will have the idea about that one. What is network, what is host, you will have with this one. If you see here, you need to remember, in class C we have one N and remaining is H. One network, remaining is host. In class B you have 2 network and 2 host. And class C 3 network, 1 host. And here subnet mask we are using. Subnet mask is used to identify the network and the host portion. I am saying subnet mask. Whenever we are configuring the IP address in any machine, what we will do, we will write the IP address and then we will write the subnet mask also. So why we are using subnet mask? Subnet mask is used to identify the network portion and the host portion. We are using this one to identify which one is a network portion, which one is a host portion. To identify that one, we are using the subnet mask. So now you need to remember, when you are using the class A, you will have the subnet mask 255.0.0.0. Or we can use another form. This is a notation form. You can write a /8. Okay, you can use as a /8 also. We can use this way also. So what we are doing, we are writing here /8. Okay, /8. And if you see here, we are using the class B. In the class B we are using 2 network portion, that is a 2 times 255, 255 and 2 times host, that is 0, 0 here. Okay, and we have the network here, network here, network here, and this is a host. So in simple words, you need to remember, in class A we have 1 network portion, 3 host portion, and wherever you have the network portion you need to write 255, and wherever you have the host portion you need to write .0.0.0. Okay, and then another thing, wherever you have the class B you need to write the 2 network portion. So 2 times 255.255.0.0, and whenever you have the class C you will write the 3 times network portion, and remaining is the host portion, and host portion will be 0. And 255 one time means /8, because this is a 8 bit, and 2 time means this is 8, this is 8, that is 16 /16. And if you see this one, this is 8, 8, 16 plus 8, 24 plus 4, 24. So here we are checking, this is a 8 bit /8, this is a 16 bit /16, this is a 24 bit /24. So just you need to remember, you can represent subnet mask like this way or this way also. You need to remember, class A means /8, class B means /16, class C means /24. Okay, and here 1 time n, here 2 time n, here 3 time n. And here if you see class A, class B, class C, class D, we are saying, so the IP which is coming from 0 to 126, 0 to 126, that come under the class A. We can say 127 also come under the class A, but this is used for the loopback testing purpose. This one 127 we will use for the loopback testing purpose. So we can say this come under the class A, but we will not assign to our machine. We will assign to our what we can say, we will use this one for testing purpose. So do not be confused. We will not use the 127. Okay, we will not consider this one in the class A, class B or class C, but actually this come under here only. But we are not using this one. This is a special type of IP. We will keep this one for the testing purpose. So that's why we will not write here. Okay, we will have from Z1 to 126 as a class A, from 128 to 192 whatever IP we are using, that come under the class B, and class C is nothing but 192 to 223 will be the class C. and from 224 to 239 will be multicast, 240 to 255 will be the reserve for O&D, that is the research and development purpose. They reserve that one. Okay, so I hope this is clear. From 1 to 126 is a class A. 127 will be for testing purpose, so we will not assign, that's why I did not write here. In the more IPs we are going to check that one also. Here I mention here 127 what we are doing, so I will discuss this one also, no worries. Okay, so let's see what else we have. Till here everything is okay, right? Because this is a basic, this is a concept you need to understand, because always we are using the IP address whenever we are doing any lab. Always we are using the IP address whenever we are doing any lab. So it is good to have the idea about this IP address. So now what I will do here, if you see, this one is clear, and what we are saying just now as we discuss here, what we discuss, 255 means network. So here same thing I am saying, 255 is representing the network bit and 0 is representing the host bit. Okay, 255 is representing the network bit and 0 is representing the host bit. We will discuss that one. Imagine, let me take the example 192.168.1.0. Whenever, let me write first of all this one. Here I will write 1. The IP start from here 1. If you write in the place of 1 here, if you write 0, that will consider as a network ID. Okay, network ID. How we will write the network ID? If you remember, still we did not move in the routing protocol, that's why we don't know network ID and we did not done the subnetting. But you need to remember, whatever IP you will write, example you will write 1.2.3. something, you will not use 0 and you will not use 255. 0 is for the network ID and 255 is for the broadcast. So these two things will be not used. So whenever you have any IP, example, imagine this one, as we are using always this one, 192.168.1.0. This IP we cannot assign. And if you take 192.168.1.255, this also we cannot assign. This is a network ID, this is a broadcast ID, so we will not use this IP to configure our machine. Okay, so what else? If you see here, this one till now we discuss here, right? Let me check what else question, if anyone is. If I use 1.1.1.1, this is a class A. Okay, why I am saying class A? This is in this range, from this range, and I can write /8 because class A we can write /8 also. This is one IP. Another IP what will be? I can write 1.1.1.2 /8. This is also same network. Or if I make this 2.2.2. This is also same network. How I am saying this is same network? Because if you remember in class A, we need to remember this, only one thing should be match, remaining not necessary. Whatever we have, we can leave that one. So this one is N, this one is N. So this match, remaining no issue. Remaining no issue. Even if you have 2 here, if you have 1 here. Let me show you here one example. Let me take the packet tracer. Okay, and here what I will do, I will take 2 machine. Okay, this is my machine 1 and machine 2. Okay, now I will take here, I will go to desktop, I will assign IP here 1.1.1.0 as the doubt. I assign this one. Okay, let me go here 1.1.1. okay, so this is the by default we came this subnet mask. This is a class A, and let me connect also this one and go here 1.1.1. anything I can take 2. It is not necessary all 3 should be same. Here I wrote all 3. Only first digit need to be same because this is a class A. Wherever you are writing 255, only that digit should be same. Remaining should, if you are writing 00 means anything. We can have 2, 3 something. But anyhow, let's try to ping and verify it is working or not. If you remember, same subnet, that is the same network, will work, different network will not work. So I will write here ping and I will paste the IP address here. If I ping here, it is working. Why it is working? Same network. Now I will go here, I will write here, instead of 2.1.1.1 something I will write here. Okay, this is a different network. Why? This is a 2. You need to match this first digit both the side, but I write 2.1.1.1. Now let's see it will work or not. I will go here, I will write here 2.1.1.1. if you see here, it will not work here. Why? They are different network. How I am saying different network or same network? See here, in class C, class A, we are doing class A 1 till 126. You can take any IP, okay, from 1 to 126. So I will write here 1 dot, I will use 3.2.4, okay, and other PC IP will be 1.5.2.4. It will work, but if you make this as a 2, because first digit should be match. In class A, if you remember, /8, or we are writing one time n, the remaining is host. So it will not work if we do this way. Let me show you. Let me change the IP here and verify that one. This is my IP. I have 1.1.1. Instead of this one, I will change this here 1.3. and 2.4. okay, and here same thing, whatever I assign here, I will go to the PC2, I will assign here whatever we discuss here. Instead of 2, first of all I will write the 1.5.2.4. okay, so I will copy this one. By saying this is a different, right, by saying they look like different, but this is for class A, only first digit match, remaining no issue. So I will go here, I will ping this one. Let me ping here, ping, and let me remove this IP. I will write this IP, whatever IP I copy from there, I will ping. It is working. Why it is working? Because this is a class A and the first digit match. This is a class A first digit match, so it is working. But if I change the first digit, it will not work. So I will go to the PC2, I will change the first digit. Okay, so here I will make this as a 2, or maybe I will make this as a 100, because what we are saying, class A is from 1 to 126, so I can give 100 something also, okay, but it will not work, because as per our rule, the first number will be same in the both side. Here we have 111, but here other side we have 100, because we are using class A, means first number should be same. If you are using different class, that is class B, means 2 numbers should be same. If you are using class C, means first 3 number should be same. If it is not same, it will not work. You need to use the router in between them. See here, it is not working. Okay, so what we are saying here, let me show you. Till here is okay, right? Till here it is okay. This is a basic, just what we discussed. And now if you see, class A is, we are saying /8. So how many computers can get the IP from class A? If you see here, /8 means network portion. If we are saying, if you remember, just now we told /8. /8 is nothing but network. One network, 3 hosts. Just now we told one network, 3 hosts. In class A, one network, 3 hosts. Okay, so what we done here, this is a network, 3 hosts means how much? This is 8, this is 8, this is 8. 8 plus 8, 16, 16 plus 8 is 24. So what we will do, 2 power 24. So what value you will get, that value will be the number of hosts you can connect in the class A. Let me repeat again. See here what I am saying. If you take class A, we have one network part. If you take class A, we have one network part and the remaining will be the host part. So you are giving the IP to the host. Host means your computer. You are giving the IP to the host. So how many hosts you have? You have 3 hosts. So each host part is having the 8 bit. So we will add this all. We have 3 portion for host. So we will add, so it will be 24. So the formula will be 2 power 24. So whatever this number is coming, that many hosts can get the IP from the class A. And if you move to the class B, if you remember in class B we are saying 2 times n and 2 times host. So we need to check host, this is 8 plus 8 and this should be 16. So this 16 number will move to 2 power 16. If you see 2 power 16 means 65,000. So if you are using class B, you can get the IP for 65,000 host without subnetting. If we do subnetting, we can do play with that IP again. But now with this one we will have, this is a standard. And if you see class C is nothing but /24. And in this one you have the 3 network bit, 3 network portion. That and one only the one host portion. So host portion is 8 bit. So you will write 2 power 8. That is nothing but 256. So if you are using class C, you can assign the IP address to 256 host only. If you have more host, you can go for the class A or class B. Okay, so you need to remember class A default subnet mask is 255.0.0.0, or we can write like this way also /8. And class B default will be 2 times 255 and .0.0, and we can write /16. Class C is we can write 3 times 255 and .0 and /24. This one also we can do. And if you convert the this one into binary, we have 8 bit. So we will write this 0 in the 8 time. Again this 0 will be in 8 time. Again this 0 will be in 8 time. And 255 means all are 1, so this all are 1. Here you have 255 2 times, so all are 1, 2 times 8 bit and remaining 0. This one we are going to do detail in the subnetting class. Just we are discussing the IP, so you will have the idea about the IP. We are assigning the IP and we are saying the subnet mask, so we will have the idea about the IP. That's why we are discussing in the high level. This is a class C, 3 times 255 255 255.0. So if you see here 255 means all are 1. This is a 2 power 0, 2 power 1. In detail we will do in the subnetting 2 power 1, 2 power 0, 2 power 3, 2 power 4. So with this one we will get this value like 8 bit means we will write 8 times 0, 1, 2, 3 and we will put 1, 1, 0, 0. We are going to see that one in the subnetting. Now just remember, this is important, you need to remember from here to here whenever we are doing the subnet this labs, because in lab we are going to use this one in the routing protocol. So this is very important. And now after that we have the private and public. We will do this one and we will close class. So next we will continue in next class. Okay, so let's discuss the what is private IP and public IP. Let me show you here. You need to remember this range from 1 to 126, this 3, at least you need to remember this 3. So if you get any IP from this range, example I will get 192 dot anything 1.1.1, here should be /24 because this IP is coming from the class C. Okay, but sometime you will see instead of /24 you will have /22, sometime 16, sometime 8 or /26, something different, or /32. Means that time we have subnetting is done to this one. Okay, so in subnetting class we are going to discuss that in more detail, but now just you remember, without subnetting if you are using this will be /8, this should be /16 and this should be /24. Okay, and let's go here to our private and public IP, and before that one let me see private and public. So here we have two types of IP here also. You have the private and you have the public. So private means whatever we are using inside our organization. Example, if your organization you have this router, ISP give you some IP, that is public IP. Maybe you have like 200 something you have some IP from the ISP here, but you are using the network like 192.168.1.1. this is a private. So private IP we can assign to any machine, no problem. anywhere we can assign. So just you need to remember, inside whatever we are using in our organization, that is a private, and private IP is free, no need to buy. This is a free, we can use anywhere, and it is not registered, it is a unregistered IP. It is unique within the network, means in our network it is unique, but if any other network, if you are checking in your company, you are using this IP, but if I check in my company, I am also using this IP, because this is unique inside the organization, only inside the organization, but not globally unique, and it is free, everyone can use. But with this IP you cannot access the internet, you cannot go to the internet by using the private IP, you need to have the public IP to access the internet. So what we can say, this IP is used in the organization, it is free, it is unregistered and unique within the network, and not recognized on internet, means you cannot access the internet, and no one can access you because this IP is not recognized on the internet. Then we will go for public IP. What is public IP? Public IP is nothing but it is used in the public network. Public IP is nothing but we use this one in the public network, and it is not a free. Public network means you can access the internet, and it is not free, we need to pay to the ISP or INA to get that one. The one which we are getting the internet connection, the service provider, that is internet service provider giving us the internet connection, that is nothing but public IP. He is giving us the public IP, and it is not free, we are paying for this one, and it is registered, means if I am using one IP, you will not use that same IP. Let me show you here what IP is I am using here. Let me go here, I will write here what is my IP address. Okay, when I wrote what is my IP address here, this is my IP address. I am using 37.216.13.130. so I am using at present, so no one is using this one, you cannot use this one. Okay, you cannot use this one, I am using this one. This is a unique, this is a globally unique, means if I am using, you cannot use this one, and it is registered IP, and it recognizes the internet. In simple words, if I say private means everyone is using, but you cannot access the internet. Okay, and it is not recognized on the internet. Public means if I am using, you cannot use that one, and ISP is giving this one, this is not free, we need to pay to the ISP or INA to get this IP, and it is registered and we can access the internet. That's all in the private and public. If you see the range, the private IP address, what is the range of the private IP address? This is 10.0.0.0 till 10.255.255.255. This complete range is in the class A, that is private. Class A is there, but only this 10 block, that is 10.0.0.1, 10.0.0.2, 10.0.0.3, so on till 10.255.255.255. They reserve this 10 block for the private, means anyone can use this one, and they reserve one more block from the class B, that is 172.16.0.0, means from here it will be 1, 2, 3, 4, 5, so on till this should change from 16 to 32, and this should be 255, means this range they give. We can use this one in our network, inside in our organization, means this is a private, so this range defined by the INA. And in class C also they define the range, that is 192 168. After that 0.0.0, means in the 0 you will have 0.1 0.2 0.3 till you will get 192 168 255.255. this will be as a class C. So just you need to remember this three classes is having the one block, that is range from here to here as a private. So in our network we can use, this is a free, we can assign to our machines. Okay, so same thing here I mentioned, this is a IP address range, that is 01 to 126 and 128 to 191 and 192 to 203. The same thing what we discussed here, it is represented. network part, host path, and how we will write in 255. And here we discuss 127. We are saying class A is having 127. 127 come under the class A, but it is not used. The range from 127.0.0 till 127.255.255.255 we cannot use. It is used for the loopback and testing purpose. So this 172 is used for the testing purpose. Example, if you want to check your Ethernet card or your LAN card is working or not, how you will check? You will go here. You will go in the CMD and you will write here ping, and you can ping 127 dot, you can write 0.0.0.1 like this way, or you can write 255, anything you can write, but I am writing here 0.0. last one 1. So reply is coming means we can say my LAN card is working good. So this is for testing purpose. We are using 127. So they reserve this complete block from 127.0.0.0 till 127.255.255 is fully reserved for loopback purpose, for testing purpose. If you want to check your LAN card is working or not, we can ping like this 127.0.0.0. If reply is coming means your LAN card is good. If it is not coming means your LAN card is not good. Okay, same thing what we discussed here. I put the picture, so by seeing that one you can identify private IP range. Here just you need to remember this is a private IP range and this is a IP range for the classes. 1 to 126 is class A, 128 to 191 will be class B, and 192 to 223 will be class C, and this is class D, class E. Okay, so this is just basic about the IP address. And next class we are going to discuss about APIPA, what is a APIPA, and about the classful and what is classless IP, and then what is unicast, what is broadcast, what is multicast. So with this one we will finish the IP, and then we will look how we can assign the IP address in the different operating system. Hello everyone. If you remember, in our previous class we discussed the IP. Because we are doing the labs, we are saying this is a IP, so it is better to know the what is IP and different types of IP and how we can assign the IP. So in our previous class we discussed the IP address. Let me revise some points. We told we have the IP address class A, class A, class B, class C, class D, and class E. We are going to use only these three in our lab. This is for multicast, and this is reserved for research and development. So this one we discussed, and we told IP also we have two types, IPv4 and IPv6. This is the IPv4. IPv6 we are going to discuss later. So in IPv4 we told it is a 32-bit and it is having the network portion and the host portion, and it is having the 4 block. As we discussed in our previous class, we have 4 block 1, 2, 3 and 4. Each is having the 8-bit, what we discussed in our previous class. Okay, and what else we told? We told the IP classes and the subnet mask. If you remember, class A we told, let me write here, let me take this and erase this and write here, so subnet mask, and we told that subnet mask for class A will be 1 time 255 and remaining will be 0.0.0, and we can write also /8. And for class B we told 255 2 time and remaining will be .0.0, and we told this is /16, and class C will be 3 time 255 3 time, and after that .0, that should be /24 as we discussed. And 255 is nothing but network part, and remaining will be the host part, whatever we have. So in class A we have 1 network part, in class B we have 2 network part, in class C we have 3 network part, as we discussed this in our previous class. And also we told we will not use 2 IP. Example, if I give the example, let me write here like I have 192.168.1.0. so this IP we will not use, and another IP 192.168.1.255. these two IP we are not going to use, we are not going to assign to our machine. This IP is known as network ID or network address, and this one is called the broadcast address. So just you need to remember, you cannot use .0, and in the place of here you cannot use 255. I am saying this is for class C, this one, as I am taking the example of class C. In the subnetting class we are going to discuss more detail about this all classes, how we can divide. But now for this one you need to remember, if you take the example of this one, .0 that we will not use, we will not assign inside our computer, inside our machine, and it is represented as a network address, that is a network ID. And if you write instead of 0255, that is known as broadcast ID, that is broadcast address. This is also we are not going to assign to our machine. This one we learned in our previous class about the IP. And also we told we have two types of IP, private and public. If you remember, private and public. Private we told we can use anywhere, it is free of cost, but we cannot go to internet. But public means we need to pay the money to the ISP to get that one, and we can access the internet with this one. We can use anywhere to access the internet, and here this should be unique, globally unique, and this is only inside the network it is unique. But you can use this private in your network, I can use in my network. So this one till now we discuss. So now we are going to continue the remaining thing. And also we told about the loopback 127.0.0 till 127.255.255.255. This is a loopback IP. This one is used to check our internet, that is internet card or Ethernet card or LAN card is working or not. Okay, different name for the LAN card. Some guys are saying LAN card, some guys are saying interface card, some guys are saying internet card. So that is nothing but our LAN card, where we will connect our Ethernet cable or where we will connect to our internet, this one. So this card is working or not, if you want to check, we will check by typing 127.0.0.1. If reply is coming, we will say my LAN card is okay. If reply is not coming, I will say my LAN card is having the issue. So this is a overview of whatever we discussed in our previous class about the IP. Now we are going to look for the APIPA. So this is also important concept. You need to know about this one, APIPA, because in interview you will get this question also. They will ask what is APIPA and what is APIPA stands for and when it is going to work, what time this one is going to work. So first of all you need to remember, APIPA is nothing but automatic private IP address. So this one, when you will get this one, example, in the real scenario, if you are working in the organization, you will have the DHCP server. If you see here in this picture, we will have one server. We can make the DHCP server as a router also. Let me show you here. This is a router R1. We can say we can do some configuration here and this router behave as a DHCP server. In the coming classes, when we go for the DHCP concept, we are going to discuss about that one. But now to clear the APIPA, we need to know what is APIPA and how it is working. We need to know about some information about the DHCP server. So we can say we have DHCP server. We can make our router also as a DHCP server, or you can run your Linux machine also DHCP server, or you will have the Windows server 2019, 2000, whatever available in your organization. You can use the Windows server. By default, many organization is using the Microsoft Windows server to make the DHCP server. They have the feature that is services available. They will activate that one and they will assign the range from where we need to give. But first of all, let me explain you what is DHCP server. DHCP means Dynamic Host Configuration Protocol. The full form for this one is a Dynamic Host Configuration Protocol. At present, we are not discussing this in detail, but just I am giving you high level overview about this one. We have DHCP separate concept in our CCNA. We are going to do more detail in that DHCP class. Now you need to remember, if I say in simple words, in plain English, you need to remember this is a server which is going to give the IP address. Maybe you are thinking, why I need the IP from the server, why I will not assign manually. Okay, you can assign manually. Imagine you have your organization, you have 200 client. 200 client means 200 laptops or PC or desktop. You have 200. It is very difficult, go one by one, assign the IP and change the IP. If anything change, you need to go to each and every place and change the IP address of the machine. Maybe you are thinking, I know how to change, everyone know how to change the IP. No, everyone will not know. If the guy who is working in the HR, if the guy who is working in the finance, he don't know about the IP also. Many guys we see, they don't know what is IP also. They are working, they know the Tally software, they are expert in the Tally for the accounting purpose, they are expert in their field, but they don't know anything about the IT. They don't know what is IP address and how to configure IP address. So it will be very difficult if you want to teach them, or if you want to go and each and every machine and assign the IP. So to overcome these types of problem, what we will do, we will use the DHCP server in the organization. So DHCP server is a server which is going to give the IP to our computer. Automatically our computer is going to get the IP. Whenever you plug the LAN cable, whenever you will take the LAN cable, and whenever you are going to connect the LAN cable to a laptop, you are going to get the IP address from the DHCP server. Or if you are using the wireless network, same thing, you will get the IP address from the wireless network also. Depending upon the configuration, you will get, like you will get the IP address, and you will get the subnet mask, and you will get the DNS. Whatever is configured in the DHCP server, you will get that one. So what I am saying, now we have the concept that DHCP is a server. DHCP server is the server who is responsible to give the IP address to our computer. Now we know this one. Okay, and how it is going to give, when it is going to give, we are going to check this in detail in our DHCP class. Now we know that DHCP server is a server which is going to give the IP address to our computer. Our computer is going to get the IP from them. Okay, so now imagine if this server fail, then how about our machine? If the server fail, automatically our operating system is going to assign the IP address to our machine. That IP address assigning process is known as APIPA. So from APIPA we are going to get the IP address. So we can say, whenever DHCP server fail, then APIPA feature is going to give the IP to our machine, that is our computer. Okay, and we will say, see here what we are saying, DHCP server. The guy who is giving the IP address, it is known as DHCP server, and the guy who is requesting for the IP, it is known as DHCP client. Because whenever we connect our LAN cable to this machine, he will send the request, he will do broadcast, he will say DHCP discovery, he will send the DHCP discovery, means he will say I am looking for the DHCP server. He will send the packet in the network, and if no one reply and he will not get the IP, then the operating system of this computer is going to assign the IP to himself only, means automatically he is going to get that IP. That is known as APIPA. So in your own words you can represent like automatic private IP address is a feature in the operating system such as Windows that enable computer to automatically self-configure an IP address and the subnet mask when the DHCP server is not responding or not reachable, or when DHCP server is not giving the or not offering the IP address. So in your own words you can define, whenever we have the issue with the DHCP server, our machine will check. If he is not getting the IP, he is going to automatically self configure an IP. That IP we are going to get from the APIPA, and it is defined by the range that is 169.254.0.1 to we will have 169.254.255.254. We are going to get from this, starting from here to here, in this range we are going to get that IP, and we will have the subnet mask will be 255.255.0.0. So this is a range you need to remember. In interview they are asking, so you will say whenever our server is failed DHCP server, our operating system is giving the IP, and that IP lie in this range with this subnet mask. Okay, so this is simple topic, very easy, and we are going to do the one lab and we are going to verify that one also. If you see here what we happen, let me check, someone is joining I think now. Okay, so what we are saying here, if you see here, our DHCP server fail here. Our DHCP server fail here. So after failing, what we have the APIPA IP. We get the APIPA IP from that range. Okay, so let's see, and we will do a small lab for this one. So what I will do, let me take the switch. I will take switch here. I will take points. See here, we are discussing the APIPA. We are discussing the APIPA. So before going to APIPA, I am saying DHCP server. DHCP server is a server which is going to give the IP address to our all machines. If this server fail, automatically our computer is going to get the IP. That IP we will have in the range 169.254.0.1 to 169.254.255.254. Okay, and this is in the range. What we are saying? We are saying APIPA is a feature that is going to give the IP address to our machine. Okay, so now we are going to do this lab. So what I will do, I will take one switch and then I will take some machine. So we can take any PC. Let me take this PC, any 2 or 3 PC, and after that what I will do, I will take the cable to connect this one. Even if I take one PC, it is enough. Just I want to show you when we will not have DHCP server, how our machines are getting the IP from the APIPA. Okay, so just I want to show you that one only. So let me make little zoom, and if you see, I will go here in the desktop and I will go inside the IP configuration. If you see here, this is the static. We will assign the IP from ourselves, whatever IP we want to give. But in organization, when we are using the LAN card or we are connecting with the organization Wi-Fi, we will not select this option. This option will be selected by default. DHCP option will be selected in our machine. So what we will have, we will get the IP from the DHCP server. But if you see here, we don't have the DHCP server here in this network. Only we are connected the PCs with the laptop, PCs with the switch. We don't have any DHCP server here. So what we will have, we have the issue, DHCP server is fail and APIPA is used, and we get the IP address from the APIPA range. Okay, so I hope this is clear for you. If you want, we will do for other PC also same thing. And if you want to check in our machine also, you can go to this. You can open our LAN card. Go to the LAN card, like go to the change adapter setting. Here I don't have the Ethernet. I am using only Wi-Fi card. Let me show you in the Bluetooth. Bluetooth is also not available here. But in your machine you can go and you can put the automatic option. Let me show you here. But maybe internet will disconnect if I change this one, so class will go down. But let me show you. Here I wrote obtain an IP address automatically here. Okay, if you click this one, you will get the IP automatically. I have the IP automatically. This is the option by default I keep. So whenever I am going to connect with the internet, I am going to get the IP automatically from the DHCP server, because the Wi-Fi router which I am using, he is having the DHCP server, he is going to give the IP. But if I disable, if I switch off the Wi-Fi, then I will get the APIPA IP. Okay, same thing as we discussed here just now in our packet tracer. Let me show you here. Same thing. We will select this DHCP and we will get the APIPA IP. Okay, so what we are saying, this concept which we are discussing, let me show you our notes. So this one we checked just now. Okay, APIPA. What is APIPA? And with the APIPA we are going to get the IP, and it is a feature of our window. That is our client operating system. He is going to give the IP to our machine. So now we will go for the other thing, that is classful IP address. If you remember yesterday whatever we discussed, we are saying that is a classful. Classful means you need to remember the default subnet mask. Like yesterday I told, if you take the IP, if you are taking from the class A, imagine this is example. If you are taking the class A IP address, then you will have the 255.0.0.0 for the class A. If you are using the class C, you know that in class C you have the 3 times 255.0. Okay, 3 times 255 then dot 0, like here, like this. So if you have the default value, whatever is we discuss, that is known as class full, means no subnetting is done. Just you remember whatever we told default value we have, like class A we will have 1 times 255, in class B we will have 2 times 255, in class C we will have 3 times 255. Okay, so if we are getting that same thing, that is known as class full IP address. That is a default subnet mask. Just you need to remember whatever default is coming, whatever we discuss, if you have same thing, then we will say class full. If anything is changed, then it is known as classless. If you see here in this one, this is a classless. What I am saying here, this IPv4 address which is not used, the default subnet mask, is known as classless IP address. IPv4 address which subnetting are used, means if we done subnetting, then it is known as classless. If you see this one, by seeing this one, you will say we will have 1 times 255 here, 1 times 255, or /8. We can say /8 also. But if you see here, you have 2 times 255. So maybe by seeing this one, you will say this is incorrect, because this is IP is for class A, but subnet mask is for the class B, because in class B you have 2 times 255. But this is also correct, but this is a classless. This is a classless. Classless means you will not have the default subnet mask. We will change the subnet mask. Means maybe you will have the IP for class A, but subnet mask may be for the class B or class C. So just you need to differentiate this one by seeing the IP. If you see, this is a class B IP, but if you see here, this is a subnet mask for the class C. This is a /24. This is a /16. But by default this should be /8 and this should be /16, but we are getting different. So this one is known as classless, means they are not following the classless. And if you see this one, this is a class C. In class C we need to have 3 times 255, but here we have 2 times. 2 times means 16, but we should have, this one should be /24. So this is a classless. So you need to remember, class full means by default whatever we have as per rule, that should be used. Classless means it is not using the default subnet mask, it is separate subnet mask. That is something different. So when we do subnetting, this will called as classless IP address. Okay. So hello everyone. If you see, whenever we are doing the networking concept, we will listen that it is a unicast address or a unicast. Sometime we will discuss this is a multicast, and sometime we will discuss the broadcast. So we need to know what is multicast, what is unicast, what is broadcast. So in simple words, if you want to say unicast, that means one-to-one communication. Means if you are sending to your friend, imagine you are sending one message to your friend from one place to another place, that is unicast. Or imagine you have the WhatsApp number of your friend, you are sending one message to him and he is replying to you, that is one-to-one. So we can say unicast. One-to-one communication is known as unicast. That we can connect to computer, we can do this way as a communication. If you see here example, I told I have one network A, I have another network B, and these two guys are communicating. So this one is known as unicast. Example I taken here, a device IP address. Imagine this is a device, his IP address is 192.168.1.2, and another guy is in different network. Maybe this is a router or something different. In between you will have something, but this is a one-to-one communication. So whatever one-to-one communication is going on, that is known as unicast. So you need to remember, because this will be coming in our syllabus, we are saying unicast or broadcast, multicast. So unicast means one-to-one. After that we have multicast. Multicast means one to many but not all, one to specific group. You can say from one to particular group, not all that group, particular group. Like if you say you have WhatsApp group, okay, you have WhatsApp group and you are in that group. If anyone is sending that message, you will receive that one. If you leave the group, you will not get that one. Means you are specific to that group, only then only you are going to get that message. That is known as multicast. Multicast means it is going to get you only if you are interested. If you are not interested, you will not get that one. So in this case, we will say multicast like when we configure the OSPF. Later we are going to discuss what is OSPF. OSPF is a routing protocol. So whenever we are configuring OSPF, they are going to send the multicast packets on multicast address. So this guy will send here, this guy will send here. So they will use one IP address like 224.0.0.5 and 224.0.0.6. They will have this IP address in the OSPF. Later we are going to discuss that one. So whoever is they will send to particular this address. So all the OSPF router, they are going to receive that message. So instead of sending to one particular IP, they will send to multicast address. So whoever is interested to that multicast address, they will receive all that one. Means whoever is present in that group. So just you need to remember, multicast means it is a particular group. If you are inside that group, you will get that one. If you are not inside that group, you will not get that one. That is a multicast. Here what I wrote, types of communication where multicast traffic addressed to a group on a device. Same thing that we discussed, group. And here class D, if you remember class D we told multicast, and class E as a research and development. The IP address when we discussed, we told class D is for multicast. So multicast range is from 224.0.0 till 255.255.255.255 and cannot be assigned to the host, and we cannot use this IP. As we told, we are going to use only class A and class B and class C. Only these three classes we are going to use. Okay, so in the multicast, sender transmit only one copy data and that will be delivered to many devices. Means imagine if you see this picture, we are sending some information. Whoever is interested, he will receive. This guy is interested, he will receive. This guy is interested, he will receive. This guy is interested, he will receive. But I am not sending one packet for this, one separate for this, separate for this. Only I will send one. So whoever interested, he will get one copy. So this guy is same, only one packet will transfer. This guy will receive one copy, this guy will receive one copy, this guy will receive one copy. That is known as multicast. So multicast type. And then we have the broadcast. In broadcast, like even if you are interested or not, you will get that one. If you see in the WhatsApp also, we have one broadcast list. WhatsApp we have broadcast list. So if you add that number, when you send the message to the broadcast list, all the guy whoever is present in the broadcast list, he will get the message. Even that guy is not interested, you add it in the broadcast list, he will get that message. So with this one, what we can say, one to all communication. One to all communication is known as broadcast. Types of communication where data is sent from one PC to copy to all the devices. Means all the devices is going to receive this one. If you remember, in switch we told we have one switch and all PCs are connected to the switch. Whenever we open the switch PCs early morning or whenever you go to the office, you will power on this PC. And when you power on the PC, the switch will don't know the MAC address, so he will broadcast the frame. If you remember, he will broadcast the frame. So all the guys will get the copy of that one. Same thing here also we are saying the broadcast. Broadcast means it will go to all the devices. Okay, so this just you need to remember. In simple, if I want to say you, remember unicast means one to one. 1 to 1. And then multicast means one to specific group or group, one to group, whoever is present in the group. And broadcast means one to all. Just remember like this, one to all. So you can define in your own words if you remember this 3 point. Unicast 1 to 1, multicast 1 to group, broadcast 1 to all. That's all. Okay, so this one is the about multicast and the unicast address type. So let me stop this topic here. Hello everyone. So now we are going to see the IP parameter for client. Means how we can assign the IP address to the client. We are going to check that one. Regarding the IP address, we already discussed in our previous class. It is a 32 bit, and we can say we have two types of IP address, IPv4, IPv6, and it is carrying the network portion and the host portion. This already we discussed. It is having the 4 block, each block is 8 bit, and INA is giving that one. We have the 5 classes. This one just I wrote the overview of the IP address, which we already covered this one. Okay, so this one is having the different classes, and each class is having network and the host portion, and we have the private and the public. With the public we can access the internet and we need to pay the INA, and this one is the private IP range. Till now we learn, okay, till here we already learned, just now also we discussed, and in our previous class we already discussed this one. Now we need to learn how we can assign. For example, for window, if you want to assign the IP address, how we can assign. First we already know this one, but they put in the syllabus, so it is better to discuss this one. First we need to open the control panel. You can open control panel, or from here also you can go to the network card and click the network and the internet, and click the network and the sharing center. Then on the left panel click the change adapter setting link and use the following IP address option. So set the IP address. When you click, you will have the option, you can put the IP, and we can put the subnet mask. If we have DNS, we can put the DNS. Then we press OK and OK. This is the steps what we use to put the IP address in our machine. And I put the screenshot. We will go inside the where we can say control panel, and after that we will click the network, this one, network and internet setting, just now as we discussed. After that we will click here network, internet, and then network and the sharing center, and we will go here, we will have this option, then change adapter setting. After that you will see the adapter. Example, this is Ethernet. If you want to assign the IP here, you will double click this one, and then you will have this window like this. Then click this one and you will have the window. Then if you select this one, you will get the IP from the DSCP. So now we are learning how we can assign manually. So we will click here and we will write the whatever IP, whatever default subnet mask, and the gateway. If you want to put the DNS, I am writing the Google DNS 8.8.8. We can write this one, press OK. So this way we can assign the IP address. If you want to verify did I assign correctly or not, we will open the command prompt and we will type ipconfig or ipconfig/all. So this is a method to assign the IP address in our machine. Let me show you. Already many guys know already this one, but we have in our syllabus. So see here what I done. I click this one, I go here I can go, I can change adapter setting, and wherever I need to assign the IP, I can go there. Example, this Wi-Fi. So I will click the property, and then I will go to the IPv4, and here instead of this one I will click this, but here I will not click. I will click this and I will assign the IP, then I will press OK. Or let me do here in this one, in this this is a virtual adapter. So I will go in the property, I will click here, I will click here whatever IP I want to assign, I will assign, and I will press OK. Okay, so this way we can assign the IP to our computer. And after that we have how we can assign the IP to Linux machine. If you are having the Linux machine, how we are going to assign the IP to the Linux machine. So Linux machine also easy. We will follow some commands to assign the IP. So what I will do to show you this one, I have the GNS3. Let me take the Linux machine. If you see, we have the Linux machine, that is a Ubuntu Docker. If you see, this is a Docker. I will take this Docker, I will keep this here, and I will do right click, I will start this Docker, and then I will take the console of this Docker. So it will take some time and it will open the console of this Docker. Okay, if you press, this is a Docker, it is open. Docker is nothing but it is a lightweight Linux machine. Okay, it is a lightweight. If you want to use for any purpose, we can use. Like if you take any Linux machine, if you install in GNS3, it will take lot of RAM. So instead of that one, we will use Docker because we need to run some commands only. So what I will do now, I need to check the IP address. First of all, I need to check the IP address. Do I have anything is configured in this one? So what I will use some commands to check that one. I will write if config, and then press enter. If you see here, I don't have the IP address assigned here. Okay, I don't have the IP address. So what we will do, we will assign the IP address. Remember, ipconfig is used for window to get the IP address. Ifconfig is used for the Linux. So what I will do here, I need to assign the IP address. Example. So how we will assign? I need to write here if config, and after that ETH0, because I am writing here, I need to assign the IP to this one. If you see this ETH0, this interface. So which interface I need to assign? I need to write IP config and that interface, and then give the space and write whatever IP you want to assign. Example, I want to assign 192.168.1.100. Let me take 100 or anything I can write. Whatever you want to write, right? After that, if you want to write the subnet mask, then we need to write net mask, and then give whatever net mask you want to give. Net mask is nothing but subnet mask. Example, I want to give this one. After that, press enter. So with this command, I assign the IP. And now if I want to check, how we will check? If config. If I type if config, before we don't have any IP. If you see here, this is a IP, whatever I type here just now. And this is a net mask. Okay. And by default, he calculated the broadcast IP of this one is last digit, because this is a class A. Class C, if you see, this is a 3 times 255. Okay, so I am using the default mask. Default mask means whatever by default we have, I am writing that one only. So what he will think, this machine is thinking, this is a class C. Let me write here, this is a class C, and this portion is network, this portion is network, this portion is network, this is a host portion. So he will change the host portion to 255. When we change the host portion to 255, that one is known as broadcast address. So this is a broadcast, automatically they bring. What we assign only this IP address, and we assign this subnet mask. In the Linux, we are calling that is net mask. Okay, so with this way, we can assign the IP address. And now, if you want to assign the gateway, that is, gateway is nothing but what we can say, like in our machine, if we want to assign the default gateway, same thing. If we want to assign here in the Linux, how we will do? We need to write root, and after that add, and then default GW, and give space and write. Example, I want to give default gateway as 192.168.1.1, and which interface we will use? Ether0, right? So we will write Ether0 and press enter. And after that, if you want to check this gateway you assign is correct or not, you need to write root and press enter. So with this way, you will get that one default gateway, whatever you assign, that is present here. Okay, 192.168.1.0. So this is a method to assign the IP address and default gateway in the Linux machine, as we have in our syllabus. So we done that one, and I already mentioned in the notes. So when you are referring, I will upload these notes also, so you can see whatever we done here. Same thing, we use this command to assign the default gateway and the IP address, and how we done, we use the Linux Docker in the GNS3, and we put that command here. Okay, just now what we done, and gateway we done, and if we want to check, we will check with this command. Just now whatever we check, that one. Okay, so with this one we learn how we can assign the IP to our window as well as Linux to the different operating system. Hello, in this one we are going to discuss about the lab, how we can assign the IP address. So in this video we are going to learn how we can assign the IP address. Before this one, we know what is the IP address and how we can use what is the difference class A, class B, class C. All the IP address we discussed already. So now in this class we are going to learn about the how we can assign the IP address to the switch, to the router, or all the devices whatever we are going to use in our networking. For this GNS3 and packet tracer, we are going to learn that one. So if you see, I have one switch, I have one PC, and let me show you how we can assign here. Just click here and go in the desktop and click the IP address, and here press the static and you will assign the IP address. Generally we are using the class C for our basic purpose, for lab purpose. You can use anything. I will write 10 and automatically subnet mask will come, because this is a class C and class C will have 3 times 255 255 255. That's why it came 3 times 255.255.0. and default gateway, we don't have router, so we will not write the default gateway. Default gateway is nothing but a entry or exit point, we can say, our the main door where we want to go outside. We need to cross that door. So now we are working inside the network, so no need to write the default gateway. I assign this one and I will take one more PC. Let me take one more PC here and connect. I will take the automatic cable. I will connect this automatic cable to this switch, and in this now we are going to do the lab, how we can assign the IP. So what IP I assign, I will put the label here. Let me put the label. I think I assign 192.168.1.1, and here my idea to assign here same network, I will take this one 192.168.1.2. I think I assign here 1.10. Let me check here what IP I assign here. If you see 1.10, let me check what you wrote. Yeah, 1.10 I assign. So let me copy here directly. Copy this one and paste here. Copy here and paste here. So it will be easy. And here let me take 11. So I will assign this one as 11. How we will assign in the PC? I will go inside. I will go here. I will paste this one. Automatically subnet mask will come, and gateway we don't have, so I keep this one. An example, now I can check they can communicate or not, because they are in the same network. So what I can do, I can go in the command prompt and I can write the ping. So let me take like this. Let me move like this so you can see. So I will write ping 192.168.1 dot we will write 12, right, or 11. This one is the 11. My question to you, this will ping or not? If I wrote this one, it will ping or not? Not. Yes, you are correct, because we don't have that IP address in our, let me show you also, because that is 1.12. we don't have 1.12 in our network. Yeah, you are correct. So that's why we will not have any reply. Reply will we will have request timeout, because we don't have that IP address in our network. So now I will ping the 1.11. So with 1.11 means if it is within our network, and as well as we have one PC which is assigned this IP, so it will work. So both are working. We can say okay, they are working, no issue.
Hello everyone, I am Paswati Bania. First of all, I'd like to welcome for enrolling this IPv4 tutorial. Inside IPv4 tutorial, we will be learning about the overview of IPv4 tutorial, and we'll also be learning about the OSI model, TCP IP model, and there are packet structures of the IPv4, and there are many addressings, addressing type and the address classes, subnetting, and BLSM and reserved addresses, and the example of IPv4. And this tutorial is designed for the beginners to understand the basic concept of IPv4 required to work with the TCP IP based protocol. After completing this tutorial, you will find yourself at a moderate level of expertise of IPv4, where you can take yourself to the next level. Before you start the proceed this tutorial, I am making an assume that you are already aware of basic concept of the basic computer and the network concept, such as what is protocol, why do we need protocol, and the network layer. If you have this prerequisite, you are welcome to continue this course. So I will see you in the next video. Hello everyone, welcome back. It's me, Paswati Bania, and today we'll be talking about the IPv4 overview. And as we know that this is an era to be said to be that the era of computer. Computer have sufficiently changes the way we live. Our computing devices, when connected to other computing devices, enable us to share data and information at light fast speed. As we know that, what is computer network? A computer network or a network is the word a computer is said to be a collection of interconnected hosts via some shared media which can be wired or wireless. A computer network enables its hosts to share and exchange the data and information over the media. Network can be a local area network spanned across an office or metro area network spanned across a city or wide area network which can be spanned across city and provinces. A computer network can be as simple as two PC connected via a single copper cable, or it can be grow up the complexity where every computer is connected to the world is connected to every others called the internet. A network then including more and more components to reach its ultimate goal of exchange data, and here are the some brief description of the component that involved in the computer network. Host. Host is said to be situated at the ultimate end of the network. For example, a host is a source of information and another host will be the destinations. Information flow in between hosts. A host can be user, PC, and internet servers, or data server, etc. Media. If wired, then it can be a copper cable, fiber optical cable, and coaxial cable. If wireless, it can be free-to-air radio frequency or some special wireless band. Wireless frequency can be used to interconnect remote sites too. Hub. A hub is a multi-port repeater and it is used to connect hosts in a LAN segment. Because of low throughput hubs are now rarely used, but hub work on layer 1 physical layer of OSI model. Switch. A switch is a multi-port bridge and it is used to connect hosts in a LAN segment. Switches are much faster than hub and operate 1 wide speed. Switch work on layer 2, which is data link layer, but layer 3 network layer switches are also available. Router. A router is layer 3 network layer devices which make a routing decision for the data or the information sent from remote destination. Routers make the core of any interconnected network and the network. Gateway. A software or combination of a software and hardware put together work for exchanging data among networks which are using different protocols for sharing data. Firewall. Some of combinations of software and hardware used to protect user data from unintended recipients on the network or internet. All components in a network ultimately serve the hosts. Hosting addressing. Communication between host and can happen only if they can identify each other on the network. In a single collision domain, where every packet sent on a segment by one host is heard by every other host, host can communicate directly via a MAC address. MAC address is a factory-coded 48-bit hardware addresses which can also uniquely identify a host, but if a host wanted to communicate with a remote host not in the same segment or logically are not connected, then some means of addressing is required to identify the remote host uniquely. A logical address is given to all hosts connected to the internet, and this address is also called as Internet Protocol address. This is the end of the video, guys. Hope you understand the overview of IPv4. So guys, see you in the next video, and in this video we'll be talking about the IPv4 OSI model. Have a good day, guys. Enjoy. Hello everyone, welcome back. Net Expert here. I am Paswati Bhania. I will be mentored through this video. In this video, we are going to talk about IPv4 OSI model. As we know that the international standard organizations have a well-defined model for communication system known as Open System Interconnection or the OSI model. This layered model is a conceptualized view of how one system should communicate with other using various protocols defined in each layer. Further, each layer is designated to a well-defined part of communication system. For example, the physical layer defines all the components of physical nature: wire, frequency, pulse code, voltage transmission, etc. for a communication system. The OSI model has the following 7 layers, and on the topmost application layer, which also known as layer 7, and presentation layer, which also known as layer 6, session layer, which is also known as layer 5, transport layer, which is also known as layer 4, network layer, which is also known as layer 3, data link layer, which is also known as layer 2, physical layer, which is also known as layer 1. And now we are going to get some detailed information about each layer. Application layer, as well as also known as layer 7. This is where the user application seek that needs to transfer data between or among hosts. For example, HTTP, file transfer protocol, and electronic mail is the example of application layer or layer 7. Presentation layer, which is also known as layer 6. This layer helps to understand data representation in one form on a host to other host in their native representation. Data from the sender is converted to on the wire data, generally standard format, and at the receiver end, it is converted to the native representation of the receiver. And session layer, which is also known as layer 5. This layer provides session management capabilities between hosts. For example, if some hosts need a password verification for access and if credentials are provided, then therefore the session password verification does not happen again. This layer can assist in synchronization, dialog control, and critical operation management. And for example, an online banking transaction. Transport layer, which is also known as layer 4. This layer provides end-to-end delivery among hosts. This layer takes data from the above layer and break into a smaller unit called segment and then give it to the network layer for transmission. Network layer, which is also known as layer 3. This layer helps to uniquely identify hosts behind the subnets and define the path which the packets will flow or be routed to reach the destination. Data layer, which is also known as layer 2. This layer takes the raw transmission data, signals, pulses, etc. from the physical layer and make data frame and send to the upper layer and vice versa. This layer also checks any transmission error and sort in out accordingly. Physical layer, which is also known as layer 1. This layer deals with hardware technologies and actual communication mechanisms such as signaling, voltage, cable type, and length, etc. Network layer. The network layer is responsible for carrying data from one host to another. It provides means to allocate a logical address to host and identifying them uniquely using the same network layer. Take data unit from transport layer and cut them into the smaller unit called data packet. Network layer define the data path. The packet should follow to reach the destinations. A router is on this layer and provide mechanism to route the data its destination. You guys understand the IPv4 OSI model. in this video, as we have said to you that if you have any questions or the confusion regarding IP4 OSI model, feel free to reach me on the social media. Hello everyone, welcome back to our YouTube channel, and today we are going to talk about IPv4 TCP IP model, and I am Paspati Bania. I will be the mentor in this video. As we already know about the TCP IPv4 model, and there is a majority of the internet uses of a protocol suite called the Internet Protocol Suite, also known as TCP IP protocol suite. This suite is a combination of protocols which encompassed a number of different protocols for different purpose and need. Because the two major protocols in these suites are TCP, Transmission Control Protocol, and IP, Internet Protocol. This is commonly termed as TCP IP protocol suite. This protocol suite has its own reference model which it follows over the internet in constant with OSI model. This model of protocol contains less layer. As you can see on this display, there is a two model. One on the left side there is a OSI reference model which contains 7 layers, and on the my right side there is TCP IP reference model which contains only 4 layers. As let's see the OSI model. If you have already watched my previous video, I have explained about the OSI reference model, and in this video we are going to discuss about the TCP IP model. In OSI model there is a 7 layer which ranges from the topmost layer, also known as layer 7, or application layer, presentation layer, session layer, transport layer, network layer, data link layer, and that up top to down there is a one last layer which is also known as layer 1, which is also called as physical layer. This is the OSI reference model. And as we come to the TCP IP reference model, there is a application layer, transport layer, internet layer, and the link layer. In TCP IP reference model, application layer do the functions of application layer itself, presentation layer, and the session layer. If you compare to the OSI reference model and the TCP IP reference model, as you can see that TCP IP reference model do the TCP IP reference model of the layers, the topmost layer, application layer, do the functions of application layer itself, including presentation layer and the session layer. And we can see transport layer, and in OSI reference model network layer is in the name of, we counter the name of internet layer in the TCP IP reference model. And there is a lowermost layer is called link layer. Link layer does the functions of that link layer and itself is physical layer. And you can see there is a figure comparative description of OSI and TCP IP reference model. This is the, on my left side there is a OSI reference model, on the my right side there is a TCP IP reference model. This model is indifferent to the actual hardware implementations. Is that the physical layer of OSI model. This is why this model can be implemented on almost all underlying technology. Transport and internet layer correspond to the same pair layer, as the top 3 layers of OSI model are compressed together into a single application layer of TCP IP model. Internet Protocol version 4 or IPv4. Internet Protocol is one of the major protocols in the TCP IP protocol suite. This protocol works at the network layer of the OSI model and at the internet layer of the TCP IP model. Thus, this protocol has the responsibility of identifying host base of their logical addresses and to route data among them over the underlying network. IP provides a mechanism to uniquely identify host by an IP address schemes. IP uses best effort delivery is that it does not guarantee that packet will be delivered to the destination source, but it will do it the best to reach the destinations. Internet Protocol version 4 uses 32-bit logical address. Hope you guys understand the IPv4 TCP IP model. If you have any questions and queries, feel free to reach me on the social media, or if you are watching this from the YouTube channel, then feel free to comment in the comment sections on the YouTube channel, so we can communicate together together, and the questions or the query that you have arises can be resolved properly. Okay, so guys, this was today's video. See you in the next video. In the next video we are going to talk about the packet structure, IPv4 packet structure. So guys, enjoy, have a good day. Hello everyone, welcome back. Network Expert here, and I am Pasupati Bania. I will be your mentor in this video. In this video we are going to talk about IPv4 packet structure. Internet protocol, being a layer 3 protocol, OSI, take data segment from layer 4 transport and divide it into packet. IP packet encapsulates data unit received from above layer and add to its own header information. And the header information contain IP header and layer 4 data. And IP encapsulations. Encapsulation data is referred to as IP payload. IP header contains all the necessary information to deliver the packet at the other end. As you can see the image of IP header, on my left side there is an update which ranges from 0, 4, 8, 12, 16, 20, and to the left to right there is a version IHL, DSCP, ENCP and total length, and the version content of 0 to 3 byte, and up to the IHL which up to the 4 to 7, and DSCP 8 to 13, and ECN 15 to 14 to 15, and total length will be the 16 to 31, and the identifications will be the 0 to 15, and the flag will be 16 to 18, and the fragment offset will be 19 to 31. TTL or time to live is up to the 0 to 7, and the protocol that we'll be using in this IP encapsulation, IP header will be the 8 to 15, and the header checksum 16 to 31, which will be helped to check the any error occur while transferring the data or the packet from the sender to receiver. And there will be the source address. Source address will be the address of the sender, which is up to 0 to 31, which means 32 bit, and there will be the destination's address, which means the receiver address, the one who will be receiving the message or the any information or the packet, which is up to 0 to 31, which is 32 bit, and there is options header, which is up to the 0 to 31, which is 32 bit. Okay, and IP header includes many relevant information, including version number, which is in the context is 4, and other details are as follow. As we can see, there is a version, and version is the number of internet protocol used. That means IP, either it will be the IPv4 or it will be the IPv6. In case we are reading IPv4, then it will be the version of internet protocol used, for example IPv4. Okay, and IHL means internet header length, the length of the entire IP header. Okay, and DSCP, there is a differentiated service code point. This is type of services used by the particular packet while transferring the packet from sender to receiver. Okay, and ECN means explicit congestion notifications. It carry information about the congestion seen in the route. Okay, if there is any congestion in the route, ECN will be the one who to notify or who will carry the information related to the congestion in the route. Okay, and total length is the length of the entire IP packet, including IP header and IP payload. And these are identifications. If packet is fragmented during the transmissions, all the fragments contain same identifications number to identify original IP packet they belongs to. And there is a flags as required by the network resources. If IP packet is too large to handle, this flags tells if they can be fragmented or not. In this 3-bit flag, the MSP is always set to 0. As we know that there is a flag which denoted to the each and every of the frame that it is fragmented, or if we have to do the if we have a particular data, we have to do fragment or the not to the particular data. there is a fragment offset. This offset tells the exact position of the fragment in the original packet IP. And the another is in IP header. There is time to leap. There is TTL or time to leap. To avoid looping in the network, every packet is sent with some TTL or time to leap value set, which tells the network how many routes or the hop this packet can cross. At each hop, its value is decreasement by 1, and when the value reaches 0, the packet is discarded. It will help in providing the looping. If you have certain packet, you have unlimited number of TTL, then it will be looping the network. It will consume the high bandwidth, and all the network traffic is increase the traffic in the network. So it is better to keep the time to leap to the packet. And there is a protocol. Protocol tells the network lead at the destination host to which protocol this packet belongs to. Is that the next level protocol? And for example, protocol number of ICMP is 1 and the TCP is 6 and UDP is 17. Okay. There is a header checksums. This field is used to check the value of entire header, which is then used to check if the packet is received error free. Okay. And there is a source address, which is 32-bit address of the sender or the source of the packet. Okay. There is a destination address, which is 32-bit of the recovery, 32-bit of the receiver or the destination of the packet. And there is a options. This options field, which is used if the value of IHL is greater than 5. This option may contain value for the options such as security, record route, and the timestamp etc. And hope you guys have understand the IPv4 packet structures. If you have any questions or the queries related to IPv4 packet structure, feel free to reach me on the social media, or you can comment in the YouTube comment sections, so we can resolve your query or the doubt related to the packet structure. Then guys, see you in the next video, and in next video we are going to talking about IPv4 addressing. Till have a good time, enjoy, bye bye. Hello everyone, welcome back. Native Exploit here, and I am Pasupati Bania. I will be the mentor in this video. In this video we are going to talk about IPv4 addressing. As we know that the IPv4 address support 3 different type address mode, and they are unicast address mode, broadcast address mode, and multicast address mode. And let's talk about the first type of address mode, which is unicast address mode. In this mode, data is sent only to one destination host. The destination address field contains 32-bit IP address of the destination host. Here the client sends data to the target server. As you see on the image, there is a server, and server A, server B, and server C, and there is a client, and everyone is connected with intermediate device that might be the switch or the router. In case we have a switch, and this is connected with a switch. Each and every device is connected with a switch, and the client is sending a unicast, sending a message to the server B by using a unicast address. Unicast address means sending to the one destination. Okay. And the broadcast address mode. In this mode, the packet is addressed to all the hosts in a network segment. The destination's address field contains a special broadcast address, which is 255.255.255.255. When a host sees this packet on the network, it is bound to process it. Here the client sends a packet which is entertained by all the server. As you can see in this image, there is server A, server B, server C, and there is a client. They all are connected with a switch, and when the client sends some message in broadcast address mode, in all this message, the client who send message is broadcast to all the server nearby it. And we have here server A, server B, server C will be receiving the message sent by the client. Okay. In multicast address, This mode is mix of the previous two mode, which is unicast and broadcast. Is that the packet is sent neither destination to a single host nor all the hosts on the segment. In this packet, the destination's address contains a special address which started with 244 dot it might be x dot x dot x. That is, this is multicast address which started up from 2224, okay, 224, and can be entertained by more than one host. As you can see in the image, uh, here, uh, here a server send packet which are entertained by more than one server. Every network has one IP address reserved from the network number which represent the network, and one IP address reserved for the broadcast address which represent all the hosts in that network. Hierarchical address scheme. IPv4 use hierarchical address scheme. An IP address which is 32-bit in length is divided into 2 or 3 parts at byte. As you can see, there is a image, there is a network and subnetwork and host. All the network and subnetwork and the host which are 8-bit, which is 4 section. That means 8 4s are 32. Okay, this is 32-bit length. Okay. A single IP address can contain information about the network and its subnetwork and ultimately the host. This scheme enables the IP address to be hierarchical, where a network can have many subnetworks, which in turn can have many hosts. Okay, and subnet mask. The 32-bit IP addresses contain information about the host and its network. It is a very necessary to distinguish both. For this, router uses subnet mask, which is as long as the size of the network address in the IP address. Subnet mask is also 32-bit long if the IP address in binary and is AND with its subnet mask, the result yielding the network address. For example, saying that the IP is 192.168.1.152 and the subnet mask is 255.255.255.0, then as you see in the image, there is an IP 192.168.1.152 which is converted into the binary number, and the subnet mask which is 255.255.255.0 which is again converted into the binary form, and there is AND between IP and subnet mask, and we will get the final network, and the network will be 192.168.1.0, and the result will be here as in is in the binary form. Okay, this is the subnet mask help extract the network ID and the host from an IP address. It can be identified now that 192.168.1.0 is the network number and 192.168.1.152 is the host on that network. Okay, are you getting the point what I'm trying to say? And another is binary representations. The positions value method is the simple form of converting binary from decimal value. IP address 32-bit value which is divided into 4 octets. A binary octet contains 8 bits, and the value of each bit can be determined by the position of bit value 1 in the octet. You can see in the image there is MSB and there is SB, and the positions of the value which ranges from 1, 2, 4, 8, 16, 32, 64 and 128. That is adjustment 2 power 1, 2 power 1, 2 power 2, that goes to up to the 2 power 8. Either it might be 2 power 0 and 2 if here is 2 power 0 and 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay, there is the 8 bit. Okay, and the positional value of bit is determined by 2 raised to the power position 1. If it is raised power position 1, then it will go up to the 8. If the 2 power raised position is 0, it will go up to the 7. Okay, is that the value of the bit 1 at position 6 is 2 power 6 minus 1, that is the 2 power 5, that is 32. The total value of the octet is determined by adding of the positional value of the bit, the value is 1 1, and the remaining will be the 0. Okay, it is 128 plus 64 is equal to 192. Some examples are shown in the table below. As you can see, if we have 1 2 4 8 16 32 64 128, if one, if below we have 1, there is one bit, and rest of are 0, then there will be the 2 power 1, 2, there is a 1, then the value will be the 1. Okay, and here is the again, you can see 2 power 0, that will be the first bit will be the 0. 2 power 0 means 1. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay, if 2 power 0 will be the 1 value, and if as we can see here in 2 below we have 1. 2 power 0, it will be 2 power 0 and 2 power 1. And if we have, as you can see there, we do not have in below, we do not have 1 in below the 1. Okay, as we can see in this first row and the second row, as you can see in the second row, there is only 1 below the 2 below the 1, which means 2 power 0, 2 power 1. 2 power 1 means which is 2. And again come to the third row, as we can see we have 1 and 2. Here is a 1 bit and 1 bit. Here is we have 2 bit on, and the rest of remaining is 0. As you can see, 2 power 0 plus 2 power 1. 2 power 0 means 1, and 2 power 1 means 2. 2 plus 1 is equal to 3. Then the value will be 3. As you can see, here we have image. We can do practice and come back and check this value if you have done correct or not. Here is the value. Okay, if you have guys, this is if you have any question or the confusions, let me in the comment sections. Okay, so we can interact with each other and solve this positional value or the binary representations. Okay, so guys, this is we have come to the last in the video, and in this video we have talked about IPv4 addressing, and inside it we have talked about the unicast address mode, multicast address mode, and the broadcast address mode and the multicast address mode, and we have talked about the hierarchical address schemes and subnet marks, and we have also talked about the binary representations. Hope you have guys getting the point what I'm trying to say in this video. So guys, then this for today. Hope you are getting all the point I have explained in this video. So guys, see you in the next video. Bye bye. Have a good time.
Hello everyone, welcome back. Network Exploit here, and I am Pasupati Bania. I'll be the mentor in this video. In this video, we are going to talk about IPv4 address classes. As we know that the Internet Protocol hierarchy contains several classes of IP address to use effectively in a various situation as per the requirement of the host per network. Broadly, the IPv4 addressing system is divided into 5 classes of IP address. All the classes are identified by the first octet of the IP address. Internet Corporation of assigned name and the number is responsible for assigning the IP. The first octet refers here is the leftmost of the and the octet number are as flow splitting dotted decimal notation of IP address. As you see on the display, there is an image and there is an IP which is 192.168.1.152, 192 first octet, 168 second octet, 1 third octet, and 152 is the fourth octet. As we after converting the 192 decimal into binary number, we will be getting a 1 1, and the remaining 6 part will be the 0. As we know that 1 octet contain 8 bit. 8 bit means either it will be the 1 or it will be the 0, or it will be the combination of 1 and 0. Okay. As we know that 168 is in decimal number, if you converted that into the binary number, it will be the 10101, and remaining 3 part will be the 0 in the second octet, and the third octet is 1. So, and when you go to the right to left, if you go to the right to left, it will be starting 1, and the remaining 7 part will be the 0. If you go from the left to right, and the remaining first 1 2 3 4 up to 7 part will be the 0, and the last part will be the 1. As in the 4 octet there is a 152 in the decimal. As we convert the decimal into binary number, we will be getting the 100110000. That will be the 4 octet. Okay. The number of network and the number of host per class can be divided by this formula. As we know that how to calculate the number of network, number of network will be the 2 power number of bit. That means number of bit means on bit. Either it will always in the 1. Okay. If we encounter number of on bit means the network bit means 1. Okay. If any octet positions, if there is a if we count there is a 1, okay, we count the number of 1 means 1 bit. As to calculate the number of host or the network, we will be using 2 power host bit minus 2. Host bit means off bit means 0. Off bit means 0, on bit means 1. You need to be careful in these situations. Okay, what is on bit or what is off bit, what is network bit or what is host bit. On bit or network will be the same because they are 1, and the host bit or off bit will be the 0. And why we have to calculate the number of host? We use 2 power host bit minus 2. We subtract minus 2 because there is a network ID and the broadcast ID. Network ID and the broadcast will be containing the 2 IP, so we'll be dividing the 2. Then after dividing 2, we'll be getting the number of host in that network. Okay. When calculating host IP address, second IP address are decreased because they can't be assigned to the host. Is that the first IP of the network is the network number and the last IP is reserved by the broadcast IP. There will be the 5 classes of IP address. They are class A, class B, class C, class D and class E. Now we will be talking in more detail about each classes. Let's first of all talk about the class A address. The first bit of the first octet is always set to 0. Thus the first octet ranges from 1 to 127. Is that if we converted that the first octet, if we encounter that the 1, if there is a 1 decimal number, it converted in the binary number, it will be the, if you go from the left to right, it will be the 70 and 1. It will be the binary number. And the class A IP address ranges from 1 to 127. Okay. And the class A address only includes IP address starting from 1, because 0 is reserved by the default gateway IP. Okay. And the 127 is the loopback IP. So the class A address include only starting IP from 1 to 126. Okay, that are the IP only used by the host. That means 1 dot, that will be anything. Okay, up to the third octet, if we up to the third octet, and starting from 126.x.x.x. Okay, the IP ranges the IP range 127.x.x.x is reserved for loopback IP address. The default subnet max of the class A IP address will be the 255.0.0.0, which implies that the class A address can have 126 network, which means 2 power 7 minus 2 will be the and 16777.214 host, which is 2 power 4 minus 2. That means class A IP address format is thus, that will be the 0, and then the first octet that always set to the 0, which if we encounter the first set 0, that means this is the class A IP address. Okay. As in class B address, an IP address which belongs to class B has the first 2 bit in the first octet set to the 10, and the class B IP ranges from 128 to 191. Okay, and the class B IP address ranges from 128.0.x.x to 191.255.x.x, and the default subnet max of the class B IP address is 255.255.x.x. thus the class B has 2 power 14 network addresses and 2 power 16 minus 2 host addresses. And the class B IP address format is 10 and the network bit and the host bit. Okay. And in class C addresses, the first octet of the class C IP address has its first 3 bits set to 110. Okay. As you can see in this image, there is 110. If we convert the first octet is 110, then we can say that this is the class C IP address, and the class C IP address ranges from 192 to 223, and the class C IP address ranges from 192.0.0.x to 223.255.255.x, and the default subnet max of the class C IP address will be the 255.255.255.x, and the class C gives 2 power 21 network address, and the host address will be the 2 power 8 minus 2, and the class C IP address format will be 110, and the remaining portion of the third octet will be the network, and the remaining last octet will be the host ID. Okay. And there is a class D address. Very first 4 bit of the first octet in the class D IP address are set to 110, means 311 and 0, 1110. Okay. Give the ranges from, and the range of the class D IP address will be the 2242 to 2239. Okay. If we encounter the first octet is 1110, 311 and 0, then we can say that this is the class D IP address. Okay. And the class D has the IP address ranges from 224.0.0 to 239.255.255.255, and the class D is reserved for multicasting. Okay. And in multicasting, data is not destined for a particular host. That is why there is no need to extra host address from IP address, and the class D doesn't have any subnet max. Okay. We need to be careful that class D do not have any subnet max. And then there is the last class of IP address, that is class E IP address. Class E IP address means this IP class is reserved for experimental purpose, only for research and development, R&D, or the study. Okay, research development, or it will be used for the study purpose. IP address in this class range from 240.20.0.0 and up to 255.255.255.254. Like class D, this class 2 is not equipped with any subnet max. As we can see that class D and class E, there is no any subnet max. Okay, and class A, B, C will be having the subnet max. And this is the last end of the video, guys. Hope you guys have understand the addresses of the class, and that there is different kinds of IPv4 addresses. They are class A, class B, class C, class D, and class E. And hope you guys have understand each and every classes clearly. If you have guys any questions or the doubt related to these addresses classes in IPv4, feel free to reach me in the comment section of YouTube channel, or feel free to ping me in the social media, so we can resolve your query by interacting with these questions that have arises while watching this video. So guys, in this video we will be talking about the IPv4 subnetting. So guys, this for today video. See you in the next video. Bye bye. Have a good time. Hello everyone, welcome back to Network Exploit, and I am Pasupati Bania. Today we will talk about IPv4 subnetting. And as we already know about the subnetting, each IP classes is equipped with its own default subnet max, which bounds that IP class to have a prefixed number of networks and prefixed number of hosts per network. Classful IP address does not provide any flexibility of having less number of hosts per network or more networks per IP class. CIDR, as well also known as classless interdomain routing, provides the flexibility of drawing bits of host part of the IP address and using them as a network in network. Okay, that's called subnet. By using subnetting, one single class A IP address can be used to a similar subnetwork which provides better network management capabilities. and we will also talking about the different classes of subnet, and there are class A subnets, class B subnets, and class C subnets. And let's take more detail about the class A subnets. In a class A, only the first octet is used as a network identifier, as the rest of 3 octets are used to be assigned to host. Is that 1677214 host per network. To make more subnet in class a bit from host part are borrowed and the subnet mask is changed accordingly. Here we can take as an example that if one MSB most significance bit is borrowed from a host bit of second octet and added to a network address, it creates 2 subnets, which is 2 power 1 is equal to 2 and 2 power 1, which is n is the on network bit, and which is on bit is also known as on bit. 2 power 1 is equal to 2, which is 2 power 32 minus 2. 2 power 32 means off bit or the host bit, okay, and we have to network ID and the broadcast ID, and the 2 power 23 and minus 2 will be the 83,88,606 host per subnet. The subnet mask is changed accordingly to reflect subnetting. As you can see the below a list of possible combination of class A subnets, there is a network bits, subnet mask, bit borrowed, subnet, and host subnet. If there is 8 bit on, then the subnet will be 255.0.0.0 and the bit borrowed will be 0 and the subnet will be 1 and the total number of host per subnet will be the 16777,214. If there is 9 bit on, okay, if network bit is 9 and subnet max will be the 225.128.0.0 and the borrowed bit will be 1 and the subnet that will be 2 and the host per subnet will be 83,88,606. As we can see, if the increment network bit will increase by 1, 8, 9, 10 as the subnet max will be changing according to the network bit, and if there is a as we can calculate the subnet and the host per subnet, okay. This is the list of the class A subnets. In case of subnetting to, the very first and the last IP address of every subnet is used for subnet network and subnet broadcast IP address respectively. Because these 2 IP addresses can be assigned to a host, subnetting can be implemented using more than 30 bit in a network bit, which provides less than 2 hosts per subnet, okay. And in class B subnet, by default using class full network, 14 bit are used as a network bit, providing 2 power 14, which will be the 1638 networks, and the 2 power 16 minus 2 will be the 65534 host. In class B IP address can be subnetted the same way as a class A address by borrowing bit from the host bit. Below is the given possible combination of the class B subnetting. As we also noted that there is a network bit, subnet max, bit borrowed, subnet, and the host per subnet. If there is a 16 network bit and the subnet max will be the 255.255.0.0 and the bit borrowed will be the 0, as subnet will be 0, 2 power so there is a subnet, there can't be divided subnet because all the bit are full, so the host will be the host or the subnet will be the 65534. If there is a network 17 network bits and the subnet max will be the 255.255.128.0 and the bit borrowed will be the 1 and the subnet, if the bit borrowed is the 1, 2 power 1 will be the 2 network, and the remaining host we have to calculate 2 power host on bit or host ID minus 1, which will give the result of 32766. Here host bit is also known as off bit or the network bit is also known as on bit, okay. In class C subnets, class C IP address are normally assigned to a very small size network because it can only have 254 hosts in a network. Given below is a list of all possible combination of subnetted class C IP address, and as you can see in the below image, there is a network bit, subnet max, bit borrowed, subnet, and the host or the subnet. if there is 24 bit in bit is on, network bit is 24, and there is subnet max respected to the network bit will be the 255.255.255.0, and the bit borrowed will be the 0, network subnetwork will be the 1, and the host per subnet will be the 254. As well as the number bit, if the number bit is 25, and the subnet max will be the 255.255.255.128, and the bit borrowed is 1, and the subnet will be the 2, and the host per subnet will be the 126. As we can calculate the subnet max of the remaining classes of subnet. If we have come to the last of this video, guys. If we have any questions or the queries which is related to the IPv4 subnetting, feel free to reach me on the social media or YouTube in the comment section, so we can interact with each other and solve the query that related to the IPv4 subnetting. Let me remind you we have talked about the IPv4 subnetting. In IPv4 subnetting, we have talked about the class A subnets and class B subnets and class C subnets. And the next video we are going to talk about the VLSM, variable length subnet maxing. Till have a good time, guys. Enjoy. Hello everyone, welcome back. Network Exploit here, and I am Paspati Bania. I'll be the mentor in this video. In this video, we are going to talk about IPv4 VLSM. VLSM means variable length subnet masking. Internet service providers many face a situation where they need to allocate IP subnet to different sizes as per the requirement of customers. One customer may ask class C subnet of 3 IP addresses, and another may ask for 10 IP address. For an ISP, it is not feasible to divide the IP addresses into fixed size subnet. Rather, he or she may want to subnet the subnet in such a way which results in minimum wastage of IP addresses. As we take an example, as an administrator have 192.168.1.0/24 network, the suffix /24 pronounced as /24 tells the number of bit used for network address. In this example, the administrator has 3 different departments of the different numbers of host. The department is sales department, has 100 computer, and the purchase department has 50 computer. Account department has 25 computer, and management has 5 computer. In CIDR, classless interdomain routing, the subnet are a fixed size. Using the same methodology, of administrator can't fulfill all the requirement of the network. For that, the following procedure shows how VLSM can be used in order to allocate department-wise IP addresses as mentioned in this example. And the first stage will be to make a list of subnet possible. The sublist include subnet max /notation subnet host. Okay, and subnet max will be the 255.255.255.0, and /notation will be /24, and the host per subnet will be the 254, as well as 255.255.255.128, and the /notation will be /25, and the host per subnet will be the 126. As the /notation increases, and the subnet max also will be the change, and the respected to the host or per the subnet will be changed. Okay, as you can see in this image. Okay, and step 2 will be the serve the requirement of IP in descending order, highest to lowest. That means cell have 100 computer, and purchase department have 50 computer, and account department have 25 computer, and the management have the 5 computer. And the step 3 will be that we'll be allocating the highest range of IP addresses to the highest requirement. So let's assign 192.168.1.0/25, which subnet max will be the 255.255.255.128 to the sales department. The IP subnet with network number 192.168.1.0 and has 126 valid host IP addresses which satisfy the requirement of the cell department, and the subnet max used for this subnet has 1 that will be the as we already know that 1 byte is equal to 8 bit, and as we move from the left to right, and the first bit will be the 1 and remaining 7 bit will be the 0 as the last octet. And as in steps, allocate the next highest range. So let assign 190.168.1.128/26, and the subnet max will be the 255.255.255.192 to the purchase department. This IP subnet will now network number 192.168.1.128 has 162 valid host IP addresses which can be easily assigned to all PC of the purchase department. And the subnet max use has, as we already know that 1 byte is equal to 8 bit. If we move from the left to right, and the first and the second bit will be the 1 and the remaining 6 bit will be 0 in the last octet. Okay. Step 5, allocate the next highest range is that account department. The requirement of the account department is 25 IP can be fulfilled with 192.168.1.182, and the CIDR will be slash notation will be slash, and the respective subnet max will be the 255.255.255.224, and the IP subnet which contain 30 valid host IP addresses. The network address of the account department will be 192.168.1.192, and the last octet of the subnet max is, as we move from the left to right, 1 byte is equal to 8 bit, and the 3 bit up to 3 bit from the left to right will be the 1, and the remaining 5 it will be 0. And in step 6, allocate the next highest range to the management department, and the management department contain only 5 computer. The subnet 192.168.1.224/29 with the subnet max 255.255.255.248 has exactly 6 valid IP addresses, so this can be assigned to management department. The last octet of the subnet max will contain 5 bit 1, and the remaining 3 bit will be the 0. And by using BLSM, the administrator can subnet the IP subnet in such a way that least number of IP addresses are wasted. Even after assigning IP address to every department, the administrator in this example is still left with the plenty of IP addresses, which was not possible if he has used CIDR, which means classless interdomain routing. As we came to the last of this video, guys, in this video we have talked about the IPv4's BLSM, which is variable length subnet masking. I hope you have got the point how to do BLSM in IPv4, and if you have any queries or any queries or the doubt related to the IPv4 BLSM, feel free to reach me on the social media, or feel free to comment in the comment section of YouTube channel. And in the next video we'll be talking about IPv4 reserved addresses. So for that time, have a good day, guys. Bye bye. Hello everyone, welcome back. Network Exploit here, and I am Paspati Bania. Today we will be talking about IPv4 reserved addresses. There are few reserved IPv4 addresses space which can't be used on the internet. These addresses serve a special purpose and can't be routed outside the local area network, which means LAN. There is a private IP addresses and loopback IP addresses, link local addresses, and first of all we will be talking deep down about the private IP addresses. Every class of IP addresses, there are class A, class B, and class C, has some addresses reserved as a private IP addresses. These internet protocol or IPs can be used within a network, campus, company, and are private to it. These addresses can be routed on the internet, so packets contain these private IP addresses are dropped by the router. As you can see in this picture, there is a class A IP range and respective to the subnet max, and the class A IP ranges from 10.0.0.0 to 10.255.255.255, and the respective subnet max will be the 255.0.0.0, and the class B IP range will be the 172.16.0.0 up to 172.31.255.255, and the respective subnet mask will be the 255.250.0.0, and the class C IP addresses will be the private IP addresses will be the 192.168.0.0 up to 192.168.225.225, and the respective subnet mask will be the 255.255.0.0. In order to communicate with the outside world, these IP addresses must have been translated to some public IP addresses using NAT, network address translation, NAT processing, or the web proxy server can be used. The sole purpose of to create a separate range of private addresses is to control assignment of already limited IPv4 addresses pool. By using a private IP addresses range within LAN, the requirement of IPv4 addresses has globally decreased significantly. It has also helped delaying the IPv4 addresses exhaustion. And the IP addresses or the IP classes while using private addresses ranges can be chosen as per the size of the requirement of the organizations. Large organizations may choose class A private IP addresses, where the small organization may have the option for the class C. These IP addresses can be further subnetted and assigned to the department within an organization. And next IP addresses will be the loopback IP addresses. Loopback IP addresses, the IP addresses ranges from 127.0.0.0 to 127.255.255.255 is reserved for loopback. Is that a host is self address is also known as local host address. This loopback IP addresses is managed by within the operating system. The loopback address enable the management entirely by the within the organizations, and the loopback addresses enable the server and the client process on a single system to communicate with each other. And when a process create a packet with destination address as a loopback address, the operating system loops it back to itself without having any interface of NIC network card interface. Data sent on the loopback is forwarded by the operating system to the virtual network interface within the operating systems. This address is mostly used for testing purpose like client and the server architecture on a single machine. Other than that, if a host machine can successfully ping 127.0.0.1 or any IP from loopback range, implies that the TCP IP software stack on the machine is successfully loaded and working. And the next kind of addresses are link local address. In a host is not able to acquire an IP addresses from the DHCP server, and it has not been assigned by any IP addresses manually. The host can assign itself an IP addresses from a range of reserved link local addresses. Link local addresses ranges from the 169.254.0.0 up to 169.254.255.255. As we assume network segment where all the systems are configured to acquire IP addresses from a DHCP server connected to the same network segment. If the DHCP server is not available, no host on the segment will be able to communicate with any other Windows or 98 or the later. On a Mac OS 8.0 or later, support this functionality for self-configuration for the link local IP addresses. In absence of DHCP server, every host machine randomly choose an IP addresses from the above mentioned range and then check to answer by which mean of ARP address resolution protocol. If some other host has not configured itself with the same IP addresses, once all the hosts are using link local addresses of the same ranges, they can communicate with each other. These IP addresses can help system to communicate with they do not belongs to the same physical or the logical segment. These IP addresses are not routable. If we have come to the last of this video, guys, in this video we have talked about the IPv4 reserved addresses, and inside it we have talked about private IP addresses and the loopback IP addresses and the link local addresses. In the next video we will be talking about the example of IPv4. For today this much, guys. I will see you in the next video. Till have a good time, enjoy, bye bye. Hello everyone, welcome back to Network Exploit, and I am Paspati Bania and I will be the mentor in this video. In this video we are going to talk about the IPv4 example, And in previous video we have talked about the IPv4 reserve address. Hope you guys watched this video and found benefit or useful. And in this video we'll be talking about the IPv4 example. And IPv4 example, we will be describing about how actual communication happens on the network using internet protocol version 4, which is IPv4. And we also talk about the packet flow in the network, and there will be different kind of steps that are required while transferring the packet from network to network. Packet flow in the network, as all we know that all hosts in the IPv4 environment are assigned unique logical IPv4 address. When a host wants to send some data to another host on a network, it needs the physical MAC address, media access control, of the destination host to get the MAC address. The host and broadcast ARP, which is address resolution protocol message, and asks to give the MAC address whoever is the owner of the destination IP. All the hosts on the segment receive the ARP packet, but only the host having its IP matching with the one in the ARP message replies with the MAC address. Once the sender receives the MAC address of the receiving stations, data sent to the physical media. In case the IP does not belong to the local subnet, the data is sent to the destination by the mean of gateway to the subnet. To understand the packet flow, we first must understand the flowing component like MAC address, ARP as resolution protocol, proxy server, dynamic host control protocol, domain name system, and ATNAT, which is stand for network address translations. We'll be first talking about the MAC address. Media access control, or the MAC address, is 48-bit factory hard-coded physical address of network devices which can uniquely be identified. This address is assigned by the device manufacturer. Okay, and the ARP, address resolution protocol. Address resolution protocol is used to acquire the MAC address of a host whose IP address is known. An ARP is broadcast packet with received by all the hosts in the network segment, but the host whose IP is mentioned in ARP respond to it providing its MAC address. And the next one is proxy server. Proxy server, to access the internet, network use a proxy server which has a public IP assigned, internet protocol assigned. All the PC request to proxy server for a server on the internet. The proxy server on behalf of the PCs send the request to the server, and which it receive a response from the server. The proxy server forward is the client PC. This is the way to control internet access in the computer network, and it helps to implement web-based policies. And DHCP, which also stands for Dynamic Host Control Protocol, or DHCP, is a services by which a host is assigned IP address from a predefined address pool. And DHCP server also provide necessary information such as gateway IP, DNS server address, lease assigned with IP, and etc. By using DHCP services, a network administrator can manage assignment of the IP addresses at ease. And next one is domain name system, DNS. It is very likely that a user do not know the IP address of a remote server he want to connect to, but he knows the name assigned to it. As we take the example of youtube.com. When the user type the name of the remote server he want to connect, the local server behind the screen send a DNS query, and the domain name system is mentioned is a method to acquire the IP addresses of the host whose name is known. And next one is NAT, or network address translations. Almost all PCs in the computer network are assigned private IP addresses which are not routable on the internet. As soon as the router receives an IP packet with a private IP addresses, it drops it. In order to access servers on the public private addresses, computer network use an address translation services which is translated between the public and the private address, called NAT, or network address translations. When a PC sends an IP packet out of a private network, NAT, network address translation, changes the private IP addresses with public IP addresses and vice versa. Here we can now describe the packet flow and assume that a user want to access youtube.com from her or his personal computer. She has internet connection from her ISP, and the following steps will be taken by the system to help her to reach the destination website. And there are different kind of steps that are required. And the step 1 is acquiring an IP addresses or DSCP, and step 2 is DNS query, and step 3 is last step is ARP request. And let's talk about the first step, which is acquiring an IP addresses or DSCP. When the user's PC boot up, it searches for a DSCP or dynamic host control protocol server to acquire an IP addresses. For the same, the PC send a discovery, and if you have learned the basic networking, then it also stand for DSCP. DSCP work on the DORA processes, and the PC send the DSCP discover broadcast, which is received by one or more DSCP server on the subnet, and they all respond with the DSCP offer. DORA. D means discover, O means offer, DORR means request, A means acknowledgement. Okay, and first of all is send the PC send the discover DSCP discover broadcast, and that the broadcast will be received by one or more DSCP server on the subnet, and they all respond with the DSCP offer, which includes all the necessary details such as IP, subnet, gateway, and the DNS. And the PC send DSCP request packet in order to request the offer IP addresses. Finally, the DSCP send the DSCP acknowledgement and packet to the tells the PC that it keep the IP for some given amount of time, that is known as IP lease. Alternatively, a PC can assign an IP addresses manually without taking any help of DSCP server. When a PC is well configured and IP address details, it can communicate with other component or the other computer all over the IP enabled network. And the second step is DNS query. When a user opens a web browser and type youtube.com, which is a domain name, and the PC doesn't understand how to communicate with the server using the domain name, then the PC send a DNS query. DNS means domain name system. Okay, and send the query out of the network in order to obtain the IP addresses pertaining to the domain name. The pre-configured DNS server responds to the query with the IP addresses of the domain name specified. And the step 3, which is the last step, is ARP, means address resolution protocol request. The PC find the destination IP addresses does not belong to its own IP ranges, and it has to forward the request to the gateway. And the gateway is this scenario can be a router or a proxy server. Though the gateway IP addresses is known to the client machines, but the computer do not exchange data on the IP addresses, rather than need to the machine hardware addresses, which is laid to coded MAC, means media access control address. To obtain the MAC address of the gateway, the client PC broadcasts an ARP request saying who owns the IP address. The gateway is respond to the ARP queries, send it on MAC address. Up to the receiving the MAC address, the PC send the packet to the gateway. An IP packet has both source and the destination's address, and it connects to the host with a remote host logically, where a MAC address, media access control address, helps system on a single network segment to transfer actual data. It is important that the source and the destination MAC address change as they travel across the internet segment by segment, but the source and the destination IP address never change. Hope you guys understand the packet flow in the network, how the packet flow in the network, and the terminology like MAC address, ARP address resolution protocol, and the proxy server, and DSCP dynamic host control protocol, domain name system, and the network address translation, and the process how the system reach the destination website. I hope you guys have understand each and every step clearly. If you have guys any doubt on the query related to the packet flow in the network, feel free to reach me on the social media, or feel free to comment in the comment section of the YouTube channel, so we can communicate with other and solve the queries that arises while watching this video. In the next video, guys, we'll be summarizing the IPv4, and next video will be the last video of this lecture, IPv4 tutorial. So guys, see you in the next video. Till have a good time. Bye bye. Hello everyone, welcome back. Network Exploit here, and I am Paswati Banya. I'll be the mentor in this video. In this video, we are going to talk about the IPv4 summary. Inside this, we also talk about the private IPs and NAT and overview of Internet Protocol version 6 or IPv6 and the Internet Protocol version 4 summary. The Internet Protocol version 4 was designed to be allocated to approximately 44.3 billion address. At the beginning of Internet, this was considered a much wider address space for which there was nothing to worry about. The sudden growth in the Internet user and its widespread use the exponentially increased the number of devices which need real and unique IP to be able to communicate. Gradually, an IPS is required by almost every digital equipment which were made to ease human life, such as mobile phones, car, and the other electronic devices. The number of devices other than the computer and the router expanded the demand for the extra IPs address were not considered earlier. Allocation of IPv4 is globally managed by the Internet Assigned Number Authority, which is IANA, under the coordination with the Internet Corporation for Assignment Names and Number ICANN. IANA work closely with the regional Internet register, which in turns are responsible for efficiently distributing IP addresses in their territories. There are 5 such as RIRS. According to IANA report, all the IPv4 address blocks have allocated to cope with of the situations. The following practice were being done. Private IPs before few blocks of the IPs were declared for the private use within a LAN so that the requirement for the public IP addresses can be reduced. NAT, Network Address Translations, is a mechanism by which multiple PCs host with the private IP addresses are enabled to access using one or few public IP addresses. Unused public IPs were reclaimed by RIRS. Internet Protocol version 6 or IPv6. IETF, Internet Engineering Task Force, has designed IP addresses to mitigate the drawback of IPv4. The new IPv4 Internet Protocol address is version 6, which is 128-bit address by which every single inch of the earth can be given millions of IP addresses. Today's majority of devices run on the internet are using IPv4, and it is not possible to shift them to the IPv6 in the upcoming days. And there are the mechanism provided by IPv6 by which IPv4 and IPv6 can coexist unless the internet entirely shifted to IPv6. And the mechanism are dual IP address, dual IP stack, tunneling 6 to 4 or 4 to 6, and NAT, Network Address Translation Protocol translations, NAT protocol translations. Okay. In this video, we have talked about the summary of the IPv4. Inside it, we have talked about the private IPs, NAT, and the Internet Protocol version 6. And this is the last lecture of the IPv4 tutorial, guys. Hope you guys have understand what I'm trying to say in this video. Till guys, have a good time. Bye bye.